1.6, we're going to talk about combinations of functions, adding, subtracting, multiplying, and dividing functions by each other. Okay? When you're adding anything together, you have to have like terms. Okay? When you're subtracting, you have to have like terms. What? When you are multiplying, you have to have. What is that?
Do I go to the office? So I'm allowed to get out early today.
Yes, you got to take that down to the office. When you're multiplying, remember we distribute things in, and if I'm dividing, I can divide and cancel out like terms and then go from there. So first scenario would be this. Let's do an adding one. Let's do 2x plus 1. Let's say f of x equals 2x plus 1. And let's say g of x equals x squared plus 2x minus 1. And we want to first find f plus g of x. Which means I am finding f of x plus g of x. So I'm simply just dropping this down and combining like terms. So I'm going to say 2x plus 1 for f of x plus x squared plus 2x minus 1. So 2x gives me 4x, okay? The ones cancel, and I have x squared. So x squared plus 4x as my final simplified form of adding f of x plus g of x. Can you handle adding those together?
Yeah.
Okay. That's like the simplest form of any of this that we're doing. So I can add them together. I can subtract them. Let's go ahead and do subtraction with this. So let's say I do f minus g of x with the same f of x and same g of x. That means I have f of x minus g of x. Here's where you're going to need to put parentheses around stuff so that you remember to distribute the negative into things. I have 2x plus 1, and then I'm going to have minus parentheses x squared plus 2x minus 1. So I have 2x minus 2x, so those cancel. I have 1 minus negative 1, so I get a positive 2. And I have a negative x squared. So I get negative x squared plus 2 as my solution for adding those two functions together. Don't forget to distribute that negative. If you forget that, you're going to mess things up. So that's adding, that's subtracting, finding the sum, finding the difference of two functions. We're going to do two different functions for this next one. F of x is going to equal x squared, and g of x is going to equal x minus 3. We want to start by finding the product of these. I want to take f of g of x. So let's take f of x times g of x. When I do that, I have x squared times x minus 3. What do I have to do when I have an equation that looks like that? Yeah, you have to distribute. So I end up getting x squared times x, which is x cubed, and I get x squared times negative 3, which is negative 3x squared. Boom. Okay, and that's what they want us to do in the simplest form in that fact. Now, the last type that we could have is we could be dividing. Let's say that your f of x equals radical x squared, or radical x. And let's say your g of x equals the square root of 4 minus x squared. And they want you to take f over g of x, which is the same thing as saying f of x divided by g of x. Okay? I'm gonna do that. Then I have to rewrite it as the square root of x over the square root of 4 minus x squared. What is wrong with that? There's-
Back on the rooftop.
There is a square root in the denominator's spot.
It's a 50 cc right there.
Okay. So to get rid of a square root in the denominator spot, okay, then I have to, yeah, or this is a difference of squares, yes. Okay, 4 minus x squared, which means it has, if I factor it out, it has 2 minus x and negative 2 minus x, correct? So I can get my domain and range off of this function. I'm going to leave it like this, but then I have to state a domain and range. So my domain for this, okay, would be 0, because I can't have 0 in the denominator spot, okay? So it would be 0 to infinity. 0 to infinity. And then my other part of my domain, okay, comes from the negative 2 and 2 that we talked about. Negative 2, 2, and then from 2 to 0 as well, again, or from 0 to 2 as well. So I have all of these as my pieces of my domain. So if I took this and pieced them together, what you see is that it can go from 0 to 2 as my final domain. So the domain of this is 0 to 2 because you have to take your least and combine it with your greatest to find your domain in this case. If I plug a 2 in here, I get 4 minus 2, which makes it 0, and I can't have a 0 in the denominator spot. So that's my domain. So when you do the division ones, you have to state your domain with it in order for it to be correct. We will stop there, and tomorrow we will work on compositions of functions where it's a function in a function.
Yeah.
This is all stuff we